Section 11.3, surface area of pyramids and cones. So just like in 11.2, we're finding surface area. We really only need this second formula. So it's 1/2 times L, which is the slant height. That is the distance down the side of one of the faces, one of the triangular faces. Then, like before, we have lowercase p is the perimeter of the base, and capital B is the area of the base. So just like what we've been doing. So for the first one, we have 1/2 our slant height, which is the 11.7. This is our slant height from the point at the top to the base through one of the sides. So 11.7 times the perimeter. Well, it's a square. All sides are 8. So 8 times 4 is 32. Plus the base area. Well, it's just a square. So 8 times 8 equals 64. We throw that all in Desmos or our calculator, and we get approximately 251.2 meters squared. Number 2 is basically the same type of idea. Our surface area, because it is a square pyramid, we have the base, which is a square because it's 5 by 5, just like we had up here with our 8 by 8 square. So it's 1/2 times our slant height, which is this segment, 7.4, times our perimeter. Well, we got a 5, a 5, another 5, another 5, for a grand total of 20. And plus the base area, since the square is just 5 times 5, we throw it into Desmos and or our calculator, and we get 99 inches squared. It's the surface area of that pyramid. So number 3 is the same type of shape, a square pyramid. However, we don't have the slant height this time. We need this length, but we have the height of the whole pyramid. So what we're going to do to find the slant height is draw this right triangle in here. So it starts at the point, goes to the middle of the base, right in the middle of that square, comes out to the face, and goes back up the slant height. So we were to redraw that from a 2D standpoint, looks like that. And since the side is 16, this would be 8. The height is 3. And we want to find the slant height, which is our hypotenuse. So we use Pythagorean theorem. So we have 8 squared plus 3 squared equals L squared. That's 64 plus 9, 73 equals L squared. Square root it up, and our slant height is approximately 8.54. And now it's exactly the same thing that we were doing before. So we have our slant height, 8.4. So surface area is 1/2 our slant height, which we just found, times our perimeter, which is 16, 16, another 16, and another 16. So 64 plus the base area. Again, it's a square, so 16 times 16. So when we multiply all that out and add, we get 529.28 feet squared. We had to do a little bit more work to get there, but it was the same thing as the other two. Now we have some different type pyramids. We have a triangular pyramid. So the base is this triangle, the bottom triangle. Now the faces are also triangles because it's a pyramid. So we need, again, let's just rewrite our formula. 1/2 times the slant height times the perimeter of the base plus the area of the base. So we have 1/2 our slant height, which is 6.7. That's this distance times our perimeter. Well, it's an equilateral triangle with each side being 10. So 10 plus 10 plus 10, 30. Move that out of the way for a second. Then plus the base area. Well, the base area, the base looks like this. We have a right angle there, so we know that's the height, and the base is what connects to it. So since each side is 10 and it's equilateral, when we split this down to make a right angle, both of these sides are equal, so they're both 5. And our height is 8.7. So find the area of a triangle, 1/2 the base. I guess the whole thing's just 10. We don't need those. Times our height, 8.7. Throw that in Desmos or a calculator. We get 144 inches squared. A little bit different, but not a whole lot. Check out number 5. Another triangular pyramid. Okay, not going to do anything different. We have our slant height. We have the height of our triangle. And we have the base of our triangle. So we have everything that we need. The surface area is 1/2 the slant height, which is 12.2, this segment, times the perimeter of the base. We got a 7, 7, and 7. That adds up to 21. Plus, and then we have another triangle, equilateral triangle, as our base. We have that segment connecting the top of the triangle to one of the sides. That is our height, which in this case is 6.1. And our base then is 7. So it's 1/2 base times the height. Again, we throw that in our calculator and we get 149.45 centimeters squared. Again, don't forget the squared on your units. Don't forget the units. That's what we're looking for. All right. Last one of the pyramids before we switch over to cones. We still have that formula there. So we have our slant height here. But what kind of shape is this? Well, there's 6 sides, all congruent. They have all those little tick marks there. This is a hexagonal pyramid. So the base is a hexagon. So surface area equals 1/2 our slant height, which is the 11.3, times the perimeter of the base. Well, each side is 6. And there are 6 sides. So it gives us a total of 36 yards for the perimeter. plus the base area. Well, they just straight up give us the base area. We just have to add 95.53. Again, we throw that in Desmos or our calculator, and we get 296.93 yards squared. That's how we find the surface area of pyramids. Let's switch gears to cones. Now, because we're dealing with circles, the bases are circles, of course, we're going to have pi in our formula. You can see it right there, pi r squared, where r is the radius of the base, times pi r times the slant height, L. So for number 7, surface area equals pi times the radius squared, which is the 7. Just has it marked there, nothing fancy, plus pi times our radius again, times our slant height, which is the 11.4. So we throw that in our calculator or Desmos, we get 128.8 pi. So that's it is an exact answer. We didn't round anything. Or if we have to round and we multiply by pi, we get approximately 404.64 meters squared. Just applying that formula. All right, let's look at number 8. Little bit different, not much. Surface area equals 1, oops, not 1/2, sorry, pi times the radius squared. Well, we don't have the radius. What we have there is the diameter. Diameter equals 27 millimeters. But hopefully we remember that the diameter divided by 2 is the radius. Well, 27 divided by 2, 13.5, and that is r. So pi r squared is pi times 13.5 squared plus pi times that radius again, 13.5, but now times our height, our slant height, which is the 32.9. Throw it all in our calculator. Before we multiply by pi, it's 626.4 pi. Then we multiply by pi to get our decimal approximation. We get 1,967.89 millimeters squared. All right. We have another one like these two. However, we don't have the slant, or we have the slant height, we don't have the radius. So to find the radius, we draw this right triangle. We know the slant height is 27.3. We know the height is 25.2. So if we just take that triangle out of the picture, we got a hypotenuse of 27.3, height of 25.2, and we got to find our r, our radius, which is also one of our legs in a right triangle. So we use Pythagorean theorem. R squared equals, nope, not R squared equals, sorry, R squared plus 25.2 squared equals 27.3 squared. So when we multiply those out, we get R squared plus 635.04 equals 745.29. Subtract that 635.04 to get R squared by itself. R squared equals 110.25. Then we square root it to actually get our radius, and it's approximately 10.5 centimeters. 10.5 is our radius. So now we have enough to write our equation or write our formula. There it is. The surface area is pi times the radius squared plus pi times the radius times our slant height. This is 27.3. 25.2 is not in our formula, but we used it to find something that is in our formula. So if we multiply this out, we get 396.9 pi, or if we do our decimal approximation, we get 1,246.89 inches squared. So we just need to have the slant height and the radius. We have those two, we can find our surface area. All right, so now some applications, some word problems. So this first one, there's no diagram with it. Cone has a surface area of 822.78 centimeters. So we're starting backwards. We know the surface area. We have a diameter of 18 centimeters. So we can obviously find our radius. And then we're going to use that to find our slant height. So surface area equals. And again, I'll write this out. This is for a cone. It is pi r squared plus pi times r times the slant height. So the surface area is 822.78. We still have to find our radius. Our diameter is 2. So if we divide our diameter is 18, we divide by 2, our radius is 9. So pi times r squared plus pi times r times our slant height, which we don't know. That's what we're going to be finding. All right. So we'll just square the 9. That's all we can do there. We'll subtract 81 pi. Those cancel out. We get 568.31 equals 9 pi L. And of course, we did 81 times pi to figure out what we had to subtract from 822.78. Then we divide by 9 pi. So that our slant height equals about 20.10 centimeters squared. We had to work backwards, and then we had to solve an equation. Nothing super crazy. All right, let's take a look at number 11, surface area of the figure to the left, that cool kind of looking thing. So we have a cone stacked on top of a cylinder. Now we just want the lateral area, so the first part of our formula for the cone. So usually it's pi r squared plus pi rl. But pi r squared is just, or is the circular base, but we don't have that. This segment here, or this section, is not being counted because it's not the outside of our figure. So we don't have that. So we'll get rid of that circle. So the cone part is there. Surface area equals pi rl. That's that part. Then we'll take a look at the cylinder part. So we want pi, oops, not pi, 2 pi r squared plus 2 pi rh. But again, we don't need both bases we want this, and that's this part, plus 2 pi r h. It's got the height, so you know it's about the lateral side. And then this is both of our bases of the cylinder, the circle, but we only want one of them. So instead of the 2 there, we'll just add in pi r squared. Now we substitute in our numbers and we find the surface area. So pi r is 17, slant height is 20, plus 2 pi, radius is 17, height is 12, plus our circular base, pi r squared, and then we add up all of that, and we get 1037 pi, and if we do the decimal approximation, we get 3,257.83 meters cubed. That's a lot of area. So we could just kind of had to look at the parts that we needed. And now, number 12. The roof on a shed is a square-based pyramid. If the base has a side length of 10 and the slant height of the roof is 9.4, find the area of the roof. Well, the roof is just going to be the lateral area. It's not going to be the base because that's not part of the roof. That would be, I guess, the ceiling of inside. So we want this pyramid. It is a square pyramid, but no base. So our pyramid formula completely is 1/2 slant height times the perimeter of the base plus the area of the base. Well, we just said that we're not doing the base. So it's just the 1/2 times the slant height times P. That's it. So of our figure here, of our roof, it's just 1/2 our slant height, which they told us, 9.4, times the perimeter. The base is a square with side length 10. So that's looking up, down upon the square. 10, 10, 10, 10. We add them up, we get 40. Then we throw it into our calculator or Desmos. We get 188 feet squared. And that is how you find surface area of cones and pyramids, as well as some cool word problems.